Welcome to week 7 of Herzing's IS112 computer networks. This is the final week of this course on computer networks. This week's topic is on integrity, availability, security, and management. During this presentation, we'll examine how to ensure network availability and integrity, security best practices, and what is needed to properly manage a network. Let's begin. Integrity is the soundness of network programs, data, services, devices, and connections. Availability is how consistently and reliably the network, file, or system can be accessed by authorized personnel. Integrity and availability need well-planned and well-configured networks, including data backups, redundant devices, protection from malicious intruders. Phenomena compromising integrity and availability are such items as security breaches, natural disasters, malicious intruders, power flaws, and human error. Fault tolerance is the capacity for a system to continue performing despite unexpected hardware or software malfunction. The best method to ensure 100% uptime is to have redundancy. For example, using modern virtualized servers, if one server fails, the other server picks up the slack with no downtime. So in this example here, you have a physical server in one location that has multiple virtual servers that is backed up at a off-site location that has physical server and the same virtual server is replicated. So if this server goes down here, all the work is picked up by this server. Another example of redundancy is network feeds. The given example has a redundant internet feeds. On this diagram, you can see you have your internet and you have two different feeds to your network from the internet, so that if this feed goes down right here, you still have the feed from here. And you can see the redundancy built in. It's almost like a circular network where if one branch goes down, it could go the other route all the way around. Many times people spend a lot of money on the internet but fail to pay for redundancy. You must analyze the physical environment in which devices operate. For example, excessive heat or moisture, break-ins, natural disasters. One method to proactively monitor your physical environment is to purchase temperature and humidity monitors. Power is another major environmental issue. A sound UPS and backup power plan is necessary to ensure uptime. Most well-planned networks extensively use battery and generator devices to ensure that their networks are well-planned. So you have a lot of different options here. You can have battery, generators, different detection devices. The key thing is to control your environment and to lessen the possibility of environmental failure. Another component of integrity and availability is data backup. Backup of the network resources, including the servers, is crucial to ensure integrity and availability. Backup to tape is normally done A newer method is continuous backup to disk in another server. The advantage of using disk is that backups are done continually and no tapes are needed to restore data. Again, key thing with any type of backup, you need to keep your backups off-site. You could have all the best backup methods, you could have tape, disk, and all types of real-time backup, but if it's in one location and that one location has a natural disaster, everything is lost. Disadvantage with tape, it's sequential, it takes long to back up and it takes long to restore. Disk is not sequential, you could go directly to the data, so it's quick to back up, quick to restore. Every organization should assess security risks by conducting a security audit. This should include a thorough examination of each aspect of a network. This will determine how it might be compromised. The audit should occur at least annually, preferably quarterly. The more devastating a threat's device effects, and the more likely it is to happen, the more rigorous your security measures should be to address it. You look at this and you think it's important to identify your security risks. You have, again, it should be done on a scheduled basis, at least annually. You have internal security, external security, and you should have an outside security resource to conduct the audit. Physical security. You need to restrict physical access to components such as a computer room, switches, routers, etc. Locks may be physical or electronic. Good physical security should be required to have electronic access badges to use numeric key codes or biorecognition access. So again, physical security. Physical security, you need to restrict access, and you also need to, especially with badge readers, identify who goes in and out. Another method that wasn't mentioned here is to definitely have security cameras. Which brings us to the next slide under security and physical. Restrict physical access to components such as computer rooms, etc., but digital security cameras are great for recording and finding security breaches. The most important way to ensure physical security is to plan for it. So with security cameras, you can monitor what's going on. Security at the NOS or network operating system. Regardless of network operating system, you can implement basic security by restricting what users are authorized to do. Always limit public rights. Administrators should group users according to security needs. In this example, a group is set up for the English teachers, and the security is managed by the group, not the individual teachers. As we move away from network operating system security, the key thing is to plan. Proper planning does produce good results. You need to, by planning, you need to organize your details of a project. For example, timeline and significant tasks. Many use text or spreadsheet documents for small projects. For large projects, use project management software. You need to provide a framework for inputting tasks, timelines, resource assignments, completion dates, and so on. And that's project planning. Project managers are responsible for facilitating regular, effective communication among project participants and must communicate with stakeholders. A good manager must prepare users for changes, including the following: how access to the network will be affected, how data will be protected during changes, whether you will provide means for users to access the network during changes, and whether users will have to learn new skills. The example given right here is a common task is network downtime. Who does it affect? When does it occur? And why is it being done? This needs to be communicated. There are many more recommendations to properly manage a network. One last recommendation is to always pilot test any network project before going live to uncover any potential problems. A pilot test saves a lot of grief. If you test before going live with the entire system, you will uncover most of the common problems. In summary, to properly manage and support a network requires a lot of work. This course has introduced you to many best practice recommendations. For the long haul, you will need to continue to develop your network management skills. You have now completed the Week 7 presentation for IS112 computer networks. Always remember to try and apply what you've learned in this class outside of this classroom. This is the last presentation of this course, and I hope you learned a lot.